Example 25 asks us to solve the equation 6 tangent squared of theta plus 13 secant of theta equals 2. And it gives us a window of 0 to 360 degrees. So again, we have an equation that looks quadratic. However, we don't have the same trig functions at the bottom, so we can't use the quadratic formula or factor this way. Lucky us, we do have an identity that says that the tangent squared of theta, or x, plus 1 equals the secant squared of theta. And so this is really helpful because we have tangent squared involved with secant, regular secant. So we want to try to convert the tangent squared to a secant squared so that we can use this regular secant part. So we're going to use that. So tangent squared is going to be secant squared minus 1 if we think about moving that over. So we're going to replace tangent squared with secant squared of theta minus 1. And everything else stays the same for now. So we're going to get 6 secant squared of theta minus 6 plus the 13 secant of theta equals 2. And so when we finally put this together like a quadratic formula would normally look, we're going to get 6 secant squared of theta plus 13 secant of theta minus 8 equals 0. Okay, so now how are we going to go about solving this? How are we going to get our answers to work? So lots of options here, lots and lots of options. We could do the quadratic formula again. Now realize again that you're solving for secant of theta and not anything else. So we want to make sure to account for that at the end. So we can factor, use quadratic formula, whatever it is that you want. I'm going to try to factor this. Many ways that this can happen. We have lots of options here. I'm going to try, instead of doing 6 to start, I'm going to try 3 secant of theta and 2 secant of theta and see if I can find a pattern here. So if I do, let's see, how can I make this work? Oh, okay. Well, if I did a positive 8, this would make 16. And then 3 back from 16 makes 13. So this would be an absolute perfect answer for this. So we are going to use that to set up the rest of our problem. Again, if you did the quadratic formula, it's still completely fine. You're going to get what secant's going to be. But this is just another way. So I'm going to get that 3 secant of theta plus 8 is 0, or 2 secant of theta minus 1 equals 0. Now, we don't know stuff about secant, but we do know stuff about cosine. So what I'm going to do is I'm going to replace each of these with secant with 1 over cosine. So this is going to be 3 over cosine plus 8 equals 0. And this side will be, again, 2 over cosine minus 1 equals 0. So we can solve from here, each side. So I'm going to get 3 over the cosine of theta equals, I'm going to call this negative 8 over 1. This tells us that we're going to have 3 equaling negative 8 cosine of theta. So we're going to get the cosine of theta to be negative 3/8. So now the other side, again, we'll have 2 over the cosine of theta equals 1 over 1. We get the cosine of theta, we get 2 equaling the cosine of theta. Again, this can't happen. So we're only going to have answers from the other part. So we'll see here we got theta can equal what? So we need to go and let's look at our window again, 0 to 360. So if we go to do our arc cosine of negative 3/8 gives us 112.02. So we get 112.02. Now, where else would that occur? So if we think about our unit circle, okay, 112.02 would be like over here. It would be the same cosine as negative 112.02, so we can add 360 to that. So probably the easiest thing to do would be to do 360 minus that answer. Oops. 360 minus our answer, and we get 247.98 degrees. So both of these answers are going to work for us because of the way the cosine works. Now remember, you got to find all of the answers, so you got to make sure that you're thinking about the symmetry of the unit circle when you're going about your problem. But again, this is a problem that is a quadratic that we have to treat like one, and so that brings in factoring the quadratic formula or whatever solving method that you want.